And it's starting. Okay, we're going. So let me get to my homework page. Okay, start.
These are my favorite questions. Because I know I can always get those right.
Right. Yahoo!
Yay!
All right, question number 3. When taking samples of n, when n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed?
Okay, hold on just a minute. I have to
Okay.
go give my neighbor her dog. She just pulled up.
Okay. Sure.
Okay.
Okay. But Katie, just talking on number 3. When taking samples of n, when n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed? How do we know that? Because
when we went on to other right?
Mandy, just a minute.
I feel like it's also right skewed. Because do you remember when it had us go on another page and we had to do like the histogram things?
Right. Yes.
And I believe like when it was skewed right, like the distribution of means was also
Uh-huh.
called it. But I'm not sure if that's what it's asking.
Right. Yeah, but according to this whole chapter is if the sample is large, it becomes normal. But it doesn't say if this is large.
Yeah.
But that would, I guess, too, would be skewed right, but it doesn't give us really enough information.
Okay.
If the population is near normal, then a sample size of N5 will be sufficient to ensure normal distribution. But if a parent population is heavily skewed, then it needs a larger sample, around 30.
Right. And so, are we still on 3? Are you guys?
Right.
Yeah.
So I went on to the sampling distribution thing and did it with 5, several, and each time it came up different. So I think we could answer anything but normal.
Right.
It was either skewed right or skewed left and never had a normal answer. So I think really 2 answers on this one.
Right. Well, I would go more skewed right because the parent population is skewed right.
Yeah.
But I just don't know if.
Well, like the thing is it's not gonna be normal because
Right, it's not a big enough.
the central limit theorem says that if it's skewed, then it needs a larger sample, around 30 or more.
Yeah.
To be normal.
Okay, all right, I'm gonna go skewed right.
Yeah, it feels right.
Okay. When taking samples, I'm sorry, someone else want to read the next one?
I'll read it.
Sure. Okay, go ahead, Katie.
When taking samples of n equals 100, what was the shape of the distribution of mean histogram when the parent population is right skewed? And that would be normal, because when it's heavily skewed and it has a larger sample, then it's normally.
Okay.
From what I understand.
Okay.
Right. I think I agree.
Just do it really quick on the thing just to tell you what this one ends up getting. Whoops.
Okay.
Yeah, so it's pretty normal.
Okay. Awesome. Okay, Monica, number 5.
Okay, when taking samples of n equals 100, what was the shape of the distribution means histogram when parent population is normally distributed?
Yahoo, easy.
And that
Normal.
normal. Yeah.
Okay. When the distribution of means is normally distributed, and it says choose all that are correct, data are drawn from a population that is normally distributed and the sample size is small.
That's right.
Okay. And data that are drawn from a population that is normally distributed and the sample size is large.
Those will both be right because
Right.
sampling will also normally distributed no matter the...
Right. Data are drawn from a population that is right skewed and the sample size is small.
That's not it.
That's not right. Data are drawn from a population that is right skewed and the sample size is large.
That's
That
right.
one's good. So we have 3 checked, correct?
Yes.
Okay.
Okay.
All right. Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution. For a bell-shaped data, approximately 68 of the data will be within 1 standard deviation of the mean. About 95. Okay, we know it's not that one.
Right.
I'm not even going to waste my time reading all of it. If the sample size is large, then the sample mean will be close to the population mean mu. No, that's the law of large numbers. Yeah. If the sample size is large, the shape of the sampling distribution of the sample mean will be approximately normal.
Correct.
That's the one.
That's not the one?
It is the one.
Yeah, that is the one. Okay, I was because I would say it has to do with the shape. Okay.
Wait, what about the first one? Why would that not be right?
If the parent population from which the data are drawn is normally distributed, then the sample mean X will follow. It would, but that doesn't have to do with the central limit theorem, because the central, I can read it to you. It says the central limit theorem states that if the sample size is large, the sample mean, and this isn't, will be approximately normally distributed. Whoops.
Okay. Okay, now I was looking at my notes while you're doing that too. That makes sense. All right. Don't mind me. Continue on.
No, that's what we're here for. Believe me. I have lots of questions sometimes. Okay. Number 8. Let X be a random variable with population mean U equaling 10. The population standard deviation is 6. Suppose the sample size of 36 is drawn from this population. Okay, so let's figure that one out. So the standard deviation is 6.
Wait, the mean of the, wouldn't it be 10?
Let X
Yes, but don't you? But you take the yeah. Oh, okay. Wait a minute. Yes. Oh, okay. I'm sorry. Yeah, it's the mean. I'm doing the standard deviation. You're right. So it's gonna be 10.
I was thinking that's what you were doing. So that one.
Right.
The next question is for the standard deviation.
Okay, you're right.
Yeah, so this one we then divide
6 by the square root of 36. That's
Okay.
1, I think. I don't even think I need to put that in a calculator.
Yeah.
Yeah, it'd be 1. You're right.
Wow, I'm so smart!
We make this so hard, don't we?
I just the square root of 36 is 6.
That's right.
Okay, regardless. Okay, number 10. Regardless of the distribution of the population, if the sample size is large and is greater than 30, what would be the shape distribution of the distribution sample mean? It would be normal.
Right.
Hey, on 9, I think you might have to put 1.000 because that's for 3 decimals.
Okay.
Just a warning.
Okay. Thank you very much.
And then 11 says, what theorem would justify your response to question 10? And that's the central limit.
No.
Wait, it's not?
Large number.
What?
It would be the large number. The law of large numbers. Don't you think? Let me go back to read it.
That's a good question because it's dealing with the distribution, and the distribution deals with the central limit theorem.
The law of large numbers states that as the sample size increases, the standard deviation of the sample mean will get smaller. Okay, let's see. Regardless of the distribution of the population, if the sample size is large, what would the shape the distribution of the sample mean be?
I think it's the central limit theorem myself.
Yeah, I don't know. I think it is too.
Just because it says what would be the shape. And the large numbers deals mostly with the mean.
Okay, let's see.
To the mean.
In here it says, and you can be totally right. I just remember reading somewhere that it says students get this confused. So
right, and we're confused.
We're just like everybody else.
Where did I read that? I think maybe you're right that it is the central limit theorem. Let's see.
Are y'all gonna submit it or?
I'll submit it and we'll see. Here we go. All right, it looks like a lot of green check marks. It is all correct.
Yeah!
Yay!
Great. Wow.
That took us 10 minutes. Let me stop the broadcast.
Wow.
Okay.
Wow.
Woo! Nice.
Okay.
Wow, and I told my boyfriend I wouldn't be available till 11. Oh.
That's
Look
a
at
good, Katie. You don't
what?
need a friend yet. You're too young.
No, I'm 21.
Oh, shoot.
Well, you look really nice. You're ready to go see him anyway.
Yeah, we have a lunch date.
Nice.
Mm-hmm.
Is it pretty serious?
I don't know. We just became official like a week ago, but
Well, fun. Life's happy when you get a boyfriend.
it's pretty fun. He's
Yeah.
a really good guy.
Fun. Well,
Much
good.
better than all the guys I had in high school, but we all make mistakes. You know, it's fine.
Especially relationships. Oh, it's funny.
Better to make him before you get married, so it's okay.
Yeah.
Yeah.
And Monica, we did make peach pies on Mother's Day, and they were divine.
Oh, good.
Oh.
Gosh.
Oh, happy Mother's Day to you both.
Oh, thank you. And same to you.
No, I'm not a mother, so.
I know, but you do a lot, I'm sure, to help people. So it applies to you just as much as us.
They should just change it to like National Women's Day or something.
They really should. It would. I think it would just take a lot of hurt out of it.
Yeah, like those people that can't have children because of like infertility, or
Right.
those people who are married but they don't have kids yet. It's just awkward for them.
They should just make it Women's Day.
Yeah.
Yeah. Yeah. I have a daughter who has struggled, and Mother's Day is so hard for her. So I've just prayed the whole time, please let it get through this.
Yeah. Mother's Day can be hard.
Yeah.
For sure. We talked about that in my women's health class.
Oh, yeah?
Yeah, we were talking about Mother's Day and how it's kind of hard for a lot of people.
Yeah. Well,
And like, what about those people that like mothers passed away? That's sad.
right.
Whew.
Well, my mom passed away when I was young, so, but it does, sometimes I'll cry, but I just remember her fondly, so it's kind of nice to remember her.
Mm-hmm.
So, yeah.
All right, ladies.
All right, ladies, I will post this.
Have you
All right, see ya.
done homework? Have you started on the homework assignment?
Nope.
I haven't. And I need to because I work. It's so hard getting from Tuesday to Thursday. Oh, kills me. But I need to. I'm so bad. So, but I'm glad we're done early. I will start right now.
All
Have
right.
you started, Monica? Is it pretty?
No, it's been a crazy weekend. So,
Okay.
all right.
Well,
Well,
we'll see each other Thursday at 8.
Okay, perfect.
All right, bye now.
Y'all then. Bye.
Bye. So I'm hanging out to copy.